Let's move on to some graphing questions now. And for this part of the homework, we're given the graph of y equals to f of x, and our task is to sketch its derivative below. Now, when we're graphing derivatives, sometimes we're not able to get the exact heights, and that's totally fine. We're going to do our best to kind of just sketch the derivatives. Okay, so what I've done over here is on the right hand side here, I created this little table here, and I want to look at certain intervals, and I want to find out what the slope is or how the slope is behaving at that interval so that we can sketch its derivative. So if I take a look at the interval -3 to -2 on the original graph, that represents this part right here, and the question is, what is the slope of that linear line? Well, the rise is 2 and the run is 1, so the slope is going to be 2 from -3 to -2. So when we're sketching the derivative, when we look at this interval from -3 to 2, it has a height of 2. So I just draw a horizontal line just like that. And that's the first part of sketching the derivative. If I take a look at my next interval, which is between -2 and 0, that represents this part of the graph. Just ask yourself, what is the slope of that graph? Well, the rise is 4, the run is 2, and since that's a negative slope, 4 divided by 2, and we have a negative slope, so that'll be -2. So if I take a look at this region from -2 to 0, I now sketch a horizontal line of -2, just like that. Okay. All right, let's move on to the next interval from 0 to 1. Well, from 0 to 1, I have a horizontal line, so the slope of a horizontal line is going to be 0. So I just draw a horizontal line of with a height of 0 from 0 to 1 on the derivative. Okay, now if I take a look at this graph right here in that region, that's from 1 to 3. So 1 to 3, the rise is 4 and the run is 2. So 4 divided by 2 is going to be 2. So the slope is going to be 2 from 1 to 3. So then I just draw a horizontal line from 1 to 3, which has a height of 2 on the derivative graph. And then finally, if I look at the interval from 3 to 4, which is this part of the graph right here, what's the slope? Well, the rise is 2 and the rise is 2 and the run is 1. But since the slope is in a negative direction, that's a negative slope, so the slope will be -2 from 3 to 4. So on the derivative graph here from the interval 3 to 4, I just have a horizontal line there that represents -2. Now this is totally fine for my particular class. In the answer key, there's definitely these holes connecting the graphs, because when you have holes at the endpoints, what we're saying is that, for example, at 3, we're not saying the height is exactly 2 or -2, so we just kind of put holes at the endpoints that kind of connect the graph together, but we're not saying that the exact heights at 3 are 2 or -2, so we'll have holes there because we're kind of approaching 3 with 2 different heights. Okay, let's take a look at question number 2 now. So question number 2 is very similar to question number 1. We're given y equals to f of x, and we have a lot of linear lines for this particular graph, and our goal is to once again sketch its derivative. Okay, so let's take a look at certain intervals again from -3 to -2 on the original graph, which is this region right here. A horizontal line has a slope of 0. Okay, so from -3 to 2, we just draw a horizontal line of 0. And then on the next interval from -2 to -1, which is this part of the graph right here, what's the slope of that? Well, the rise is 3 and the run is 1. So the slope will be +3 from -2 to -1. So let's just draw a horizontal line there. So from -2 to -1 on the derivative, there's a height of 3. Okay, and then from -1 to 0, that's this region right here. I guess we're saying that the height is 3 and the run is 1, but that slope will be negative, so that's going to be -3. So from -1 to -0, we have this part right here, right? Sorry. Right, so that height is going to be -3 between -1 and 0. Okay, and then we have a small part right here. So from 0 to 1, I guess that slope is going to be -1. So a rise of 1 and a run of 1. So since that's negative, that'll be -1. So from 0 to 1, we have a horizontal line like that. And now we have a bigger slope over here. So the rise of this is what, 1, 2, 3, 4, and the run is 2. So 4 divided by 2 means the slope is going to be 2 from the interval 1 to 3. So from 1 to 3, we have a horizontal height of 2. And then finally, at the very end here, when I'm looking at the interval from from 3 to 4, I have a horizontal line, and that has a slope of 0. So I just put a horizontal line like that from 3 to 4. And once again, if you like, I guess you can put horizontal lines, horizontals, little holes here. And I guess at the very end, we don't need to have a hole there or a hole there because that height is not being shared. And I just don't know if I did that on my other graph. So if I take a look at my first graph here, yeah, actually, I guess I made a little mistake here. There shouldn't be a hole there, so let me kind of erase that, and that should fix it. Okay, so there you go. That's how you graph the derivatives for those first two problems there. And now let's keep on moving to a few more problems. I kind of like these ones a little bit better where you have to graph polynomials. We don't need to worry about certain holes. So for this particular graph here, what I like to do is I like to find the horizontal tangent lines. So there's one here at -1 on the original graph. So there's a horizontal tangent line like that. So when x equals to -1 on the original graph, the slope is going to be 0. Okay, so what that really means is if I go down to the derivative graph, there is an x-intercept. Okay, there's an x-intercept there. Okay, and if I take a look at the x values that are less than -1, which represents this region right here, okay, and if you draw tangent lines, I guess we can say we have a positive slope. All right, so when you have a positive slope, and when you graph the derivative will be above the x-axis. Okay, so if there's a positive slope, that means the derivative graph will be above the x-axis. So maybe something like that, above the x-axis. Okay. All right, so we're just sketching the derivative, right? And if I take a look at x values that are greater than -1, which is this region right here in blue, if I draw tangent lines here, I would say those slopes are definitely negative, right? So I have a negative slope when x is greater than -1, and this means that the derivative graph will be below the x-axis. Okay, so I can draw a line like that, and there is that part of the derivative. So there is a simple sketch of this parabola. When I sketch the derivative of that parabola, we're given a linear line, and that's a good sketch for this particular problem. Okay, let's keep on moving on here. All right, so let's move on to question number 4 here. And for question number 4, I have another polynomial for the original function. And maybe the first thing I'll do right now is I'll find the max and min points, and I will draw a horizontal tangent line there. Because what that really means is when we graph the derivative, we have x-intercepts because those slopes have a value of 0, right? So a 0 there and a 0 there. Right, so that's kind of like step number 1. Okay, and then for step number 2, let's take a look at the intervals when x is less than -2, which is this region right here. And if I draw these tangent lines all have a positive slope. So this means that we have a positive slope when x is less than -2. And then when we graph its derivative, this just means that you are above the x-axis. Okay, so what that would look like on the derivative graph, if I sketch it, this is above the x-axis, right? So this part right here is above the x-axis. And if I take a look at the x values that are greater than 2, which is this region right here, and if I draw tangent lines, these slopes are also positive. And if you're positive, it also means that you are above the x-axis. So this is above the x-axis like that. All right, so this is a very decent sketch of how the derivative graph will look like. All right, now the challenge is looking at what's happening in between the graph, which is between -2 and 2. Okay, so let's see if we can explain this. Let's just say we have a horizontal tangent line right there, and let's just say this has a slope of 0. Okay, and what's happening is if I draw tangent lines, the slopes here are very negative. So maybe like very negative, maybe I'll say -3. So that slope is negative. And then it becomes less negative, so maybe this slope is now -2. Then it becomes even less negative, which is maybe -1. And then as I keep on going here, maybe this is -0.5, and then levels off back to a slope of 0. All right, so it's like we start at a height of 0, we go down to a height of -3, but then we start to turn around and go back to height of -2, then a height of -1, and then we end up at 0, right? Okay, so what that kind of looks like on the derivative graph is, it kind of looks like this. So if I have a slope of -3, it kind of means like we're going down, right? We're below the x-axis, right? And then we have a height of -2, so now we're kind of turning around, and then we go back to these other more positive heights of -2, then -1, then finally we go back to 0, which is back there, right? And if I go out and really complete the sketch really more looks like a parabola. And if I draw a parabola a little bit better here, and if I erase these other pieces here, that right there represents the derivative of the above function there. So that's a decent sketch of the derivative there. Okay, so that's what's happening when we're graphing parabolas there, and when we're graphing polynomials. So if I go back to the slopes there, it's all about reading the slopes and doing your best to sketch those slopes, right? So as you can see, we have a negative slope of -3, which represents this region here, right? And then the slopes get less negative, and then it ends up back to 0, which represents this region right here in a way. Okay, so there you go. That's how you graph that derivative. Okay, let's move on to a few more now. Number 5 here. So this is great because I have another polynomial here. So let's go ahead and find the max and min points. And if I have these horizontal tangent lines here, if I go straight down, I got an x-intercept here, I got an x-intercept here, and I have an x-intercept over here. Okay, so that's how I would start off this graph here. So the slopes are going to be 0 at those 3 x values. Okay, and then let's take a look at this part of the graph right here, this part in yellow. So that's when x is roughly less than -2.5. And if I take a look at the slopes here, if I draw these horizontal tangent lines, these tangent lines here, those slopes are negative, right? So if you have a negative slope, that means the derivative is below the x-axis. Okay, so below the x-axis, if I graph that, maybe it's kind of like this, below the x-axis like that. Okay, and then I'll take a look at this other end here when x is greater than 2. So when x is greater than 2, and if I draw these tangent lines have a positive slope, right? So if you have a positive slope, I guess that means you are above the x-axis when you sketch the derivative. Okay, so maybe the graph kind of looks like this now. Okay, and then let's take a look at some of these regions right here. Let's take a look at this region right here, this green region, and that's from -0.5 all the way to 2. So what's happening in that region right there? Okay, well, when you have this horizontal tangent line right there, that means you have a slope of 0, right? And then if I draw these tangent lines, maybe that tangent line has a slope of, I don't know, -3, then maybe a slope of -2, then a slope of -1, and then we go back to a slope of 0, right? So it's very similar to the parabola, or the graph above, where we have a very high negative number first. So that means we kind of go down to like -3, and then we go back up to -2, -1, and 0. So we go back up like that. Okay, and then if I take a look at the graph over here, I'll go from left to right. So this slope is 0. And then maybe over here the slope is it's very negative, like maybe -2, then -1, and then we go back to a slope of 0, right? So oh, sorry, never mind. These slopes are positive, right? So sorry about that. Let's take a look at this regions right here. So those are positive slopes, right? So maybe that has a height of, I don't know, sorry, a slope of I don't know, maybe like 1, and then maybe a slope of 0.5, and then we go back to a slope of 0, right? So we start off with a very high slope, and then that slope decreases and then goes back to 0. So we have a very high slope, and then we go back to 0. Okay. So if I had to kind of sketch this graph here cleanly, I guess I would draw it something like this, kind of like that, and just erase all that now. And that right there represents a nice sketch of my derivative right there. Okay, so I'm not sure if that was clear enough, and I'm more than happy to talk about the slopes in class again. If I had to repeat something here, maybe I'll just repeat this particular region here. So this region right there. So what we're just trying to say is this slope is 0, and then this slope is maybe like 1, and this slope is maybe 0.5, and then back here we have a slope of 0, right? So we go from a height of, the heights would be like 1, then 0.5, then 0 if we sketch the derivative, right? So that kind of represents this graph right here, where we're going to a height of 1 there, and then we're going back down to 0. Okay, let's keep on going here. All right, so for question number 6, this one's a little bit interesting here because we don't have any max or min points. But when I look at the x value of 3, and if I take a look at the slopes here, I mean, those tangent lines, they resemble a horizontal line to me in a way. So I would say when you're greater than 3, the slopes are very close to a height of 0, very close to a height of 0. And then when you go beyond, when you go to the left of -3, everything less than 3, the slopes are behaving in a way where they are getting bigger, but it's getting bigger in a negative way, right? So maybe this has a slope of -1, then a slope of -2, then a slope of -3, then a slope of -4, then a slope of -5. And the way you graph that is that when you're in this region, when you're greater than 3, the slope is very close to 0. So on the derivative, you're almost graphing a horizontal line there almost. And then the slopes are becoming more negative. So then the graph is like getting more negative as we go to the left-hand side. So that's how you would sketch that particular graph. And I would say when you're less than 3, the slope is becoming negative, and we'll say more negative. And that's why we have the graph kind of leveling off like that, because it's becoming more negative due to these slopes that are getting more negative, right? So we're graphing that as a height on the derivative. Okay, that wasn't too bad. Let's go to question number 7 now. Okay, so for question number 7, the good news is there's a horizontal tangent line at x equals to 0. So that slope is going to be 0 on the derivative. So there's a x-intercept right there. And let's take a look at the heights, or the slope when x is less than 0. Okay, so if I take a look at that, it looks like over here the slope is going to be 0, and then the slopes become more positive, right? So if I draw these tangent lines, it's becoming more positive, and then it gets to back to a height of 0. Okay, so how do we graph this? We have a slope of 0. Then this slope starts increasing 1, 2, 3, 4, and then it gets back to a height of 0. So it's kind of like when we graph the derivative, it's like we have a height of 0 here because the slope is 0, and then the slope starts increasing. And then as we get close to x equals to 0 here, the slope just automatically crashes and goes back to 0, right? So that's what's kind of happening there. And so I'll say the slopes are becoming positive, then I'll say then crashes to 0. And that's what's happening, right? The slope is positive, and then it just crashes to 0 like that. Okay, and then what's happening on the right-hand side, so when x is greater than 0, so let's take a look at this part of the graph there. Okay, let's draw some tangent lines to kind of figure out what's happening here. So here's my tangent lines. Now it looks like over at the tail end here, the slope is 0 over there. And it looks like maybe this slope has a value of maybe, I don't know, -4, I don't know, then negative maybe 2, then -1, and then we get to maybe, I don't know, -0.5, and then we get to a slope of 0 there, right? So at the beginning, let's just say that we're very negative, so maybe we'll go down close to 4, and then we start crashing back to 0 like that. Okay, so I don't know if the heights are very accurate, but this is a decent sketch of the graph here, right? So it's very hard for me to kind of predict how high or how low you go. I'm just trying to capture the idea that we have a very negative value there, then it gets less negative, then it becomes a height of 0, which is kind of emphasized by that kind of behavior there. Okay, so do your best to sketch these graphs because it's very difficult to get the exact heights. Okay, let's look at question number 12 here. This is a good one here. I see a horizontal tangent right here. So when x equals to 0, the slope is going to be 0. So I can draw a x-intercept right there. Okay, and then I also have vertical tangent lines here and there, right? So if you have a vertical tangent line and when you're graphing its derivative, it's actually undefined at 3 and -3. So what does an undefined situation look on the derivative? It's just vertical asymptotes. Okay, so remember when you have a vertical line, the slope is undefined, right? So we'll see it does not exist. So that means the derivative will have like a vertical asymptote because the graph does not exist at those x values. Okay, perfect. Now let's take a look at this region right here. Now I'm actually looking at this region right here, which is between, this region is between -3 and 0. So if I take a look at that region right there, and if I draw these tangent lines, what's happening is that the slopes look very high here, and then the slopes start to decrease, right? All right, so it starts very high, a very high slope, and then the slopes, they still have a positive value, so you're going to be above the x-axis, but the heights are actually getting smaller and smaller, and then eventually we have a height of 0, right? So that behavior kind of looks like this, very high, and then the heights start to decrease, and then we get back to 0. And if I continue that behavior on the other side, it's going to look like this, right? So the heights here are going to be, it's actually very negative here. Then it becomes less negative if I go backwards, right? So let's start here. It's very negative over here, and then becomes less negative, and then crashes back to 0 there. So that's a decent sketch of what it looks like. So I kind of feel like the graph kind of looks like a inverse tan function there. And that's what the derivative would roughly look like. Okay, last question here, question number 13 here. So let's take a look at some of these x values here. So there's a horizontal tangent line there, there's a vertical tangent line there. So when x equals to 2, the slope is 0, and when x equals to 4, the slope does not exist because there's a vertical line there. So this means we have an x-intercept here and a vertical tangent line like that. Okay. And then if I look at this region right here, when x is less than 0, x is, I'm not sure why I have all this here. I believe we have something like when x is less than 0. And if I take a look at that particular slope, it looks like a value of -1, right? So the slope right here looks to be rise over 1. So it's positive 1 there, right? So let's see if we can deal with that first. So when x is less than 0, we have a slope of +1. So I guess that derivative looks like that. Okay, and all we have to do now is we need to figure out how to find the derivative of this slope, this part of the circle here, the semicircle there. So this slope is 0, and then the tangent lines are positive, right? And then we get very high, right? So this is interesting because maybe this has a slope of maybe 2, and then maybe this slope has a value of 4, and then maybe the slope also gets close to 5, and then we get to infinity, right? So the numbers are going from low to higher to the highest, right? So the way you graph that is it's going to look like this, shooting up like that. Okay, and then if I take a look at the other side here, if I draw tangent lines over here, so yeah, it's like this is reaching like negative infinity, -4, I don't know, -2, -1, and then we have a slope of 0 there, right? So it's kind of like we start off with 0, then becomes more and more and more and more negative, right? So it's kind of like we start at 0 and become more and more negative, and then we get very close to a very high negative number there as we approach this vertical tangent line there. What we're going to do here is we're also going to put an open circle there because definitely the derivative is not differentiable when x equals to 0. One thing that I will say here is we do have a cusp here, right? All right, so at x equals to 0, we should have something like that to make sure that we deal with that cusp. Okay, so that's it for this homework video guide. Hopefully that gives you a decent understanding of how to sketch derivative graphs. So it's very hard to get the exact heights, so do your best to just sketch them.